x
m
parentheses x minus x.
minus x squared. There we go. What does m represent here? That slope again. Where do we get y1 and x1? A point? Is it a specific point on the graph, or can it be any point? It's any point. Exactly. x1, y1 is any point on the line. x1, y1 is any point on that. What's the third form? Standard form. Yep.
Oh, I know it's standard.
Okay. What is standard form?
Ax.
Elijah? Ax plus by equals c. Ax plus by. A, B, and C represent anything in particular? No, not anything special. So standard form, though, is nice for some word problems that are a lot easier to set up in standard form if we're kind of comparing different items, maybe. But when we're graphing standard form, do it a little different than slope, intercept, or point slope because these don't represent anything. What do we usually try to find? Slope, intercept. For graphing. What 2 points? Or sorry, in standard form, not slope, intercept. What 2 points do we look for?
X-intercept and the y-intercept.
There we go, the two intercepts, the x and y intercept. X and y intercepts.
Posted video, I have to watch.
Guys, put your phones away. Okay, questions on the three forms at all? Okay. So with that, let's take a look at, let's jump to lesson 4, and then we'll come back to 1, 2, and 3. Okay.
Give me that crown.
All right. So lesson 4, we were talking about parallel and perpendicular lines. So this first part of lesson 4, group 3. This first part of lesson 4, we want to write an equation for the line that passes through the given point and is parallel to the graph of the given equation. Okay. Let's take a look at number 3 for this one. What's special about lines that are parallel?
They never touch.
They never touch. So what part of the equation tells us that they're passion? What about the slope? Same slope. Perfect. All right. For number 3 there, 3x plus 4y equals 12. What's the slope of that equation?
Or which one are we doing?
Number 3.
Oh.
Yes.
I don't know.
What form is that one written in?
Standard.
Standard form. Does it tell us slope in the equation?
Yes.
Oh, not in standard form. So we have to switch this one into slope intercept. Oh, I see.
These aren't yours, sir.
Switch it to slope intercept. So 3x plus 4y equals 12. We were trying to write it in the slope intercept form. Which variable did we solve for? Y or x?
Y.
Y. We want to get y by itself. So, how would we get y by itself? Our first step. Subtract 3x. What's 12 minus 3x? It's just 12 minus 3x. Yep. Or you could rewrite it as negative 3x plus 12. That's just fine too. The important thing, not 9, not 9x. You can't combine numbers and x's. Can't do that. Well, just keep it how it's written there. 12 minus 3. Actually, what's next? Divide by 4. No, and divide everything by 4. What's 4y divided by 4? Okay. What's 12 divided by 4?
3.
What's negative 3x divided by 4?
1.
4th x. 3x over 4, 3/4 x. How to do x? Oh. Right. Now it's in slope intercept. So now what's our slope?
3/4.
Perfect. M equals negative. So now we can finally go back and answer the question it's asking us. You want to write an equation for the line that passes through this point, negative 4, 7, and is parallel to the graph of this equation. So for our new line, what's our new slope going to be? Negative 3/4. It should be the same if it's going to be parallel. Right? So we can plug that into our equation. Y equals negative 3/4 x plus b. How do we find b? Exactly. So which one are we going to plug in for y? 7. Which one of those is our y value? 7 is the y value. X comma y, right? For the point. So 7 equals negative 3/4 times negative 4 plus b. Then what? Yeah. Right? What do we get for that?
What is it?
Negative 3/4 times negative 4. What's a negative times a negative?
A positive.
3 times 4?
0.75. Negative 0.75.
12. So 12 divided by 4?
3.
There we go. Those 4's kind of cancel out. 7 equals 3 plus b. Get b by itself. Minus 3. 7 minus 3. 4 equals b. So what's our equation for our parallel line?
Y equals negative 3/4 plus 4.
Y equals negative 3/4 x plus 4.
You can,
Questions on
if you want to.
that one at all? That one is considerably longer than the other two, just because you have to switch from standard form into slope intercept form. The other ones are all
Okay.
Check out one of the examples right below that one. Now, writing the equation of a line that's perpendicular. Okay. What do we know about the slopes of perpendicular lines? How are they different?
Perpendicular lines are the exact same. They're the exact same. They're like, or no, they cross. They cross.
Oh, I can't hear Barry. Opposite reciprocal. Awesome. Oh, are opposite reciprocal. All right. Let's take a look at the middle one here. Y plus 4 equals negative 2/3 times x minus 2. What form is that one written in?
Standard point slope.
Point slope form. So do we know the slope?
Yes.
What's the slope on this one? Oh, there's M. All right. So for our new line, what's our new slope?
2/3. Because they're opposite. So no, it would be 3/2.
3/2. There we go. Positive, that gives us the opposite. Reciprocal, flip our fraction. So negative 2/3 turns into opposite. M equals 3/2. What points are we trying to go through?
5.
For negative 2. X1, Y1 for negative 2. What's our general form for point slope?
General.
Y equals, or Y minus Y1.
There we go. Y minus Y1 equals M X minus X1. Alright. So go ahead, I'll give you 30 seconds. Use our new information here to write the equation of our new line in point slope form. Okay? And then check with your group members, see if you guys get the same thing.
Okay, so.
There's one. Not that you know. Work on the problem.
What point?
I'm done asking you guys to pay attention.
Those two minutes.
Y minus 2.
Got it, Josh? Right. Really close. Don't do this. Really close. Table 3, the die has spoken. What's your equation look like in point slope form? Negative 2, is that an X or Y value? Or Y, or an X or Y value? Which y and x specifically do those represent? X1 and Y1. Okay. So do we plug anything in for that first y? Root 3? Oh, that's still y. Y minus what? Y minus -2. What's that look like? Minus a negative is what? Positive. So y plus 2. What's our slope? 3/2. Plug anything in for x? X minus what? No. Y plus 2 is 3/2 times x minus 4. Careful on your sign. Okay? Minus a negative turns into a plus. Sometimes it's tricky with point slope because we usually default positives. But point slope defaults negative. Thanks. Questions on that one? Then let's check out one more lesson 4. What's nice about doing this one is a lot of practice of the other lesson built in here. So in this third part, here we're talking about we need to determine whether the graphs are parallel, perpendicular, or neither. Right? So which one should we go through? 7, 8, or 9? 8. I heard a lot of 8 and 9. 8. We can do 8. Because I did 9 and like 8 is. Are those two equations in the same form? Can we compare them well if they're in different forms?
Yeah.
I mean, you can, but maybe you got to think a little bit. It's a lot easier, a lot quicker to compare them in the same form. So let's turn this bottom one into slope intercept. Minus 3x minus y equals 9. Get y by itself. What's our first step here? Plus 3x. We get negative y equals 9 plus 3x. Okay, then what? By what? Not y. We're going to divide by something. You got to get that y by itself. Yeah, divide. Yep, exactly. We got to get rid of that negative sign. Divide by -1. Negative y divided by -1. That's just y. 9 divided by -1. 9. 3x divided by -1. Negative 3x. All right. What's the slope of the top equation? 3. The slope is just 3, not 3x. What's the slope of the bottom equation? Negative 3. So, comparing the slopes, are they the same thing? No. So can they be parallel? No. Are they opposite reciprocals? No. They're opposites. Are they reciprocal? No. So opposite reciprocal of 3 is what? 1/3. 1/3. So negative 1/3 is what we'd be looking for. So are they perpendicular? No. So what are they? Neither. So not same slope. Not opposite reciprocal slope.
So it's just neither.
So
You have to write on that.
you can write whatever you want in your notes. writing what might be helpful.
I agree.
All right. Questions on lesson 4 there? Let's go back and do some graphing. So Josh asked specifically for question 2 there in lesson 1. So we'll take a look at that. Jack, did you have a question or just stretch? If we have time at the end, we can come back. But it's just the same really as question 8. So if we have time, we can come back. So all right. This one here is number 2 on lesson 1. Parker, so for the last one, huh?
So easy.
Yep. That's we want to get them into the same form so you can compare. All right. This one is saying, I didn't copy the question, but it says write the slope intercept form from that graph. So to write slope intercept form, what 2 things do we need to find?
The y-intercept
Y-intercept
and the slope.
and the slope. Right? What's the y-intercept on this graph? Positive 4, so equals 4. That right here. Right? What's our slope?
2, 1/2.
1/2?
Yeah.
Negative 1/2. We're going down 1, right 2. So slope down 1, right 2 to get to like the next nice even point. So our slope m equals negative 1/2. Put those together into our equation.
Y equals
Negative 1/2 what?
plus 4.
Negative 1/2 x plus 4. There we go. Y equals negative 1/2 x plus 4. Write in the equation from the. Okay. Let's see. Any questions on that one? We'll jump over to lesson 3. That was the next requested one. And we'll do a little graphing in standard form. All right. Any of these ones in particular? I don't remember who asked for lesson 3. Ashton, was this you? Did you ask to see standard form?
Yeah.
All right. Any of those ones in particular you'd like to go through?
The second one.
The second one? Okay. So on my graph, I'm just going to add in the axes, kind of do my best to get it in the center of everything. X, Y. All right. Standard form. What 2 points of the graph are we looking for? From our, what was it, Josh?
X and Y.
X and Y what?
Intercepts. Or intercepts, yeah.
Okay, let's start with the x-intercept. How do you find an x-intercept from standard form?
Multiply the y by.
There we go. Plug in 0 for y. Because in x, guys, the x-intercept, what's our y value there at the x-intercept?
0.
0. That's why we plug in 0 for y. So, plug in 0 for y, what's left over?
Negative 3x. 12 divided by negative.
Negative 3x equals 12. All right. Get x by itself. What do we do here?
Divide by -3, get -4.
Divide by -3. 12 divided by -3.
Equals -2.
X equals -4. Alright. How do we find the y-intercept?
We'll cross out.
Now x equals 0. What are we left with there?
-6 equals 12.
-6y equals 12.
Divide to get -2.
Divide by -6. Y equals -2. So I'm going to say each of these boxes is 1 on my graph here. So our x-intercept is -4. 1, 2, 3, -4. And my y-intercept is -2. All right. And then something like that. Here's my graph. Elijah?
So I just changed the form to slope intercept and then I graphed it at
Yep.
that.
Yep. So as I was going to go into that here in just a minute. This is the most efficient way to graph in standard form, but if you don't remember this or don't remember how to do this, or oh, which one do I plug in for 0, or which one do I plug 0 into? Can't quite remember. It's always fine to switch it back into slope-intercept form, solve for y, and then just graph it that way. Come up with the same answer. That's just fine. It can just take a little bit longer in some cases. Sometimes you end up with some ugly numbers in that form, but you get to the same place, so that's just fine. Yep. All right. Any other questions there? Also, if your graph, if you did a different, what's the word I'm looking for? Scale that I did, your graph might look different than mine. When we talked about functions, what does the word domain represent? On a graph. Yep. The domain represents all of our possible x values, right? So this arrow means we're going forever and ever in that direction and in that direction. What are the possible x values we would see from this graph?
What are the possible what now?
-5.
I think it might be fair because we're wasting time for those who want to review. It might be fair to say those who just want to talk and don't want to review don't get to use notes on the line. If you're not taking the time to review now, if you're taking time away from those who want help, who have questions, maybe then you don't get help on the final. What do we think of that? Okay, show me that you guys can be respectful to those who want to review. So we said domain is all of the possible x values. All right. Does this graph stop or does it go on forever?
Goes on forever.
It goes on forever and ever in both directions, right? So are there ever any x values that line doesn't hit? No. So all of our possible x values, or I guess our possible x values are just all the numbers, right? Infinite, yep. So our domain which is all our x values, we say is all real numbers. Right? Domain is x values. Right? What about our range? What does that represent?
All possible y values.
There you go. That's all our y values. What's our range for this function?
All the numbers.
All the real numbers. It goes on forever, up and down, right? So range is also all real numbers. What does it mean to be a function? It has to pass what test?
Vertical line.
Yeah.
The vertical line test. So if I've got a vertical line and it's going along this graph, is that vertical line ever going to hit the graph twice?
No.
No, just once. So that means it's a function, right? What if I'm just going to use these other two grids here? What if I had a function that, let's say, looks kind of like a U?
It would pass the vertical line test.
Yep, that would still
But
pass.
if it's like this U, then it
If
would
we
not.
take that U and rotate it, is that what you're saying,
Yeah.
Ty?
Then it would not pass the vertical line
So if
test.
we have something like this,
I try.
that going to pass the vertical line test?
No.
Pretty much everywhere it hits twice, right? So function, not a function. What if we had something? Now this is just kind of. What if we had something that was like a bunch of alternating U's? What do we think? Does that pass the vertical line test? No. Does it not?
It does.
Looks like it does. It only hits it once. So if we flip that one though, and had it kind of like an S, would that be a function? No. Vertical line test, that tells us it's a function. Questions on that stuff with the functions? Vertical line test, domain, range. Jack?
How do you tell if it passes?
Just
It doesn't.
draw a vertical line, right? If it hits anywhere
Twice.
more than once,
But it does not.
then that does not pass the vertical line test.
Okay.
But if we have a vertical line and it only hits once, then it does pass the vertical line test. All right. Let's see. We've got enough time to take a look at that other one from 4. Right, Jack? That was the one you wanted to see?
Yeah.
Or was it
Number 9.
number 9?
I'll let you.
This one here?
Yeah.
All right. Number 9, are these two parallel, perpendicular, or neither? Okay. Are they in the same form?
No.
No, so let's get them in the same form. Y minus 7x equals 3. How do we get y by itself for that one? Plus 7x. We get y equals what?
Y equals 7x. Y equals 2 plus 7.
Plus 3. There we go. Y equals 7x plus 3. We're adding 7x to both sides. Okay, got that one taken care of. Now, 14x minus 2y equals 28. Want to get y by itself. Okay, we can add 2y. Now we've got 14x equals 28 plus 2y. What should we do before we divide? Minus 28. (14x minus 28 equals 2y). Then what, Josh? Then divide by 2. What's 14x divided by 2? 7x. Negative 28 divided by 2? Negative 14 equals y. All right. What's the slope of that first equation? Just 7. Yeah. The slope is just the number, not 7x. So 7. What's the slope of the second equation? All right. What do we know about those slopes? Same slope. So what does that mean about the two lines? Parallel. Questions there? Same slope, so they're parallel. Let's go back to lesson 2. This one here. Point slope form. If I give you 2 points for this problem, we need to do 2 things. First off, if I give you 2 points, can you find the slope of the line that goes through those 2 points? Okay. After you find the slope, then we need to take that and write an equation in point slope. So let's do 9. Okay. How do we find slope from 2 points? Parker?
Change in y.
y1 minus y2 minus y1 over x2.
Over x2 minus x1. Change in y over change in x. All right. What's y2?
Y2, you can pick one of the points.
4. Minus y1?
Negative 5. No.
1.
I was gonna
y1, yeah. And then x2?
3.
3. Then we get plus 5 because it's minus a minus 5. 4 minus 1?
4 minus 3.
3 plus 5?
7. 8.
Can we simplify that fraction at all?
No.
Nope. 3/8. You can make it into a decimal if you want, but I'd say try to keep it in the fraction. Okay, there's our slope. All right. Now, what's the formula for point slope?
Right.
Y minus y1
M
times x minus x1. All right. Do we plug in anything for that first y?
No.
So y minus, what's y1? 1. What's m?
3.
3/8. What's x1?
5. Negative 5.
So x minus a negative 5 is what?
5.